Welcome back. Last time we created a graph component, and this time I'm going to show how to add axes to that component. So the arrows, the small ticks, and the numbers on the axis. First, we'll set the background to our component to gray, so we'll easier see where the limits of the components are, or the edges. Next, we define how high the bottom axis will be. We'll just start out with a 20, and the same for the left axis, with a start value of 20 for that one as well. This will change later, but we can use these values to put an inset on our draw scope. That will adjust all the drawings so it is relative to the inset instead of the whole component. So when we draw it, we see some space to put the axis on. And now we can start drawing our axes. First we draw the arrows. So the bottom axis will have an arrow going to the right, and we'll start down in the left corner and going all the way to the right side of the component, and it will be offset from the bottom with the bottom axis height. And we create this function as a extension function on drawScope, so we have access to all the draw functions in the drawScope. And now we can draw our arrow. We use draw line. So we draw a line from the end to the start. It's the other way around, but it will make sense soon. So now we have a line at the bottom of the graph, and now we want to add the little arrowhead. So we draw another line, and it will also go from the end where the tip of the arrow is, and we will end or start at offsetted from the end of the arrow with 10 pixels, and we will offset in the Y with 3 pixels. So we have half an arrowhead, and we add the other half by just offsetting with +3 in Y instead. That's our arrow for the axis. Now we do the same for the left axis. This will be an arrow going up instead, and it will go from the left corner all the way up to the top edge of the component. And we create that function in a similar way. But this time we offset the X value with 3 pixels and the Y value with 10 pixels. There, and we should have a complete arrow going up. Next we can use these values to calculate the actual width and height of the graph area. It's just the width of the component minus the width of the left axis, and similar for the height. And now we can use these to make insets on our axes. So if we inset the axis for the bottom with these values, all the calculations for the start and end of the axis or the arrow can be calculated relative to the inset instead of relative to the whole component, which will make the parameters a bit nicer. So let's redo the calculations. Next step, I want to abstract out the concepts of the axes into its own classes. Start with the left axis. I will call it left axis graphics. And I will move in the up arrow into this class. And we create it inside our inset here. And we will give it a draw function that we will call to trigger drawing the axis. And to draw it we need the draw scope, and for this axis we also need the height of the graph component, since we actually didn't take the bottom axis into account when we did the insets. So using the scope we draw the up arrow in here, and this is the graph height now, and we put in the parameters to the draw function. Should still look the same. And now I will move up the creation of the left axis graphics up to where we have all our other variables, and create similar variable for the bottom axis. So we create that class. And we move in the drawing of the right arrow, and we create a draw function. We just copy it from the left axis, and here we don't need the graph height, so we remove that parameter. And drawing the right arrow, we should probably take the old code for drawing that and move it down. And now we can replace this by calling the bottom axis graphics dot draw and give it the scope. And now when we re-render, it looks exactly the same, but we have classes that we can put all our other axis rendering in. Next, I want to draw the ticks on the bottom axis. So the ticks are the small little lines where we will put the numbers later. I will create a function that will return a sequence of ticks. And ticks is for now just a class that encapsulates a value that is a position on the axis. And I want the ticks to be of size 5 for now. So we will return a sequence. I will just start with a few made up values so we have something to draw. We will fix this later. So at a half and a 0. Now we can say for each tick we want to draw it. And first we calculate the x value for the tick. So we ask the axis. Okay, we need the axis for that. We add it as a parameter. And we can ask the axis where on screen is the tick. And then we can draw a little line at that position. So we draw it from the top of this draw scope and we draw it down on the size of tick size. And we send the axis to our draw function. And now when we render it, we see a tick at 0 and a tick at half, 0.5. So where should our actual ticks be? To calculate that we need the axis. And the first thing we need is the minimal distance that we want between our ticks. So we require at least, say, 30 pixels between each tick. And then we can calculate how many ticks actually fits on our axis if this is the minimal distance between them. And that will be the length of the axis divided by the minimum distance between the ticks. And then we can ask the axis where our ticks should be placed. We create this function as an extension function on axis. We will return a sequence of ticks, and first we need to figure out what is the distance between the ticks in the axis coordinate system. So create a function to calculate that. This will return a float. And we want our ticks to be placed on whole numbers, or like on 1, 10 or 100 and so. So the max tick distance will be the length of the axis divided by the max number of ticks that we want to have. And we also need to know the magnitude of the axis values. So we create a function to calculate the magnitude of a number. And we calculate the magnitude by flooring the log 10 of the number. And if this is a number, we will return it. And sometimes it's not a number. In that case, we just return 0 as the magnitude. And now we can use this to calculate the closest whole number that matches our max tick size. So we take the magnitude, or the 10 potence of magnitude plus 1. And now we figure out what is the lowest value that will get a tick on our axis using this value. This might not be an actual value. If that happens, we will not return any ticks at all. But if it is a number, we will create ticks using the candidate value as the first tick value. If it's inside the axis, otherwise we will add the tick size to calculate the first tick, and then we will add the tick distance on top of the tick until we reaches the other end of the axis, and that is all our ticks for now. And now if we just run it and draw them, we see some ticks on our axis, evenly distributed. And now let's do the same for the left axis. We first calculate the ticks using the axis. This is actually the same calculation once again, but we might want to have another mean distance for the left axis. I will stay with 30 for now. There we have calculated our ticks, so now we can use them to draw the ticks on our axis. We need the axis as a parameter still. So for each tick we will draw a line at the Y value in pixels, so we convert it to a screen. And the start of the tick will have an X value of just the tick size distance from the right side of the axis, and then we just draw the line. add the axis as a parameter. And we render, and we have ticks at 1, 0 and -1 on the left axis. Next step is to draw the actual number at the ticks. So we will draw some text. And for that we need a text measurer. And the text measurer we will take as a parameter to our draw method. The text measurer is a part of the Compose API. We will draw the tick as a string, and we will use the text measurer to figure out how wide the text is and position that text as close as to the axis as possible, but we will leave room for the tick itself, and we will add a little margin before the tick. Let's make it 3 pixels. And in Y we want to place the text so it's in the middle of the tick, as to say. So we want to move it down half a character. So we measure how high a character is. We just measure the 0 here. So we will adjust it with half a character's size. And the text measurer that we need as a parameter here we can get by just saying that the text measurer is a remembered text measurer. It's part of Compose again. I'll move this around a bit, because now we need to make room for the text, so we will have to ask the left axis how wide it needs to be. So we create a method for that, and it needs to be wide enough so all the text and the ticks have room in to be rendered. So we take all the ticks and then we measure each tick and find out which one is the widest of them all. And if we don't have any ticks, we just return 0 as the max width. And we also add the tick size and the tick margin, so we have room for everything to be rendered. The last thing is that we have to override the toString here on tick, so it actually gives out the text for the position and not just the default toString. And now we render it and we see the numbers on the axis. Now I want to show another thing. If we take a graph component and resize it so it's negative size or less than 0 size, it actually crashes. So to handle that, I want to put in a if statement here to check that we actually have a size of our graph, so that the height should be more than 0 and the width should be more than 0. Otherwise we don't render anything. There, no crashing. Next thing I want to do is to actually show some decimal values between our values if there is enough room for that. For example, I want to show 0.5 and 0.25 and 0.75 if there is room for it. So we will replace our closest number here and check that if the closest number divided by 4 is actually more than our max tick size, then we actually will want to render the quarter numbers as well. So we return that as a tick, and the same for half numbers. And if we don't have half numbers, we just stay with the closest whole number. And we render now, we see our quarter and half numbers. And if we resize, we see them pop in and pop out if there is room for them or not. Next, I want to fix so that they always have the same number of decimals. And we create a function for formatting our numbers depending on if they are quarter numbers or half numbers or whatever the function decides to use. I will create a type alias for a formatter. It just takes a float and returns a string. So we can use it here in our function. So if the magnitude of our ticks are equal or larger than 0, I want to have a formatter for integer numbers, because this means that the number is larger than 0. And if we have decimal numbers, we will calculate how many decimals we want, and we create a string formatter for it that actually just cuts our float number to the number of decimals that we have decided upon. There, and we make it format the value. And now I want to be able to return both the value and the formatter here, so we return a pair instead, and we add the pair as a return value on our ticks. So for quarter values we want 1 extra decimal, and for our half values we want 0 extra decimals, and otherwise we actually want -1 extra decimal, so 1 less. Now we actually have to fix our tick method, so it takes a formatter in. The define tick distance returns a pair, tick distance and formatter, and we want to send the formatter to the tick. So we add the formatter to our tick class. and then we use the formatter to format our string value. And now when we render it, all the numbers will have the same number of decimals. Now let's add numbers to the bottom axis. First we ask the bottom axis how high should the bottom axis be. We create a method for it. So we will first measure how high a character is using the same method we did before. We just measure a 0. And the height of the bottom axis will be the height of the character plus the tick size plus the tick margin. And we will draw our numbers. We give it the text measurer that we need as a parameter. We give the text of the tick. And we calculate the position of the number. We will adjust the X position with half the width of the number. And we will put the tick size plus tick margin as the Y value of the text. We give it the text measurer, and it crashes. This is because for some reason, if we try to render text outside the window, Compose really don't like that, so we have to check that we actually don't try to render any text outside the window. And now we see our numbers on the bottom axis as well. And that's all I wanted to show in this video. Thank you for watching. See you next time.